and vacuum crystallization. Cooling crystallization involves slowly cooling the solution to allow the compound to crystallize. Evaporative crystallization involves evaporating the solvent to concentrate the solution and induce crystallization. Vacuum crystallization involves applying a vacuum to lower the boiling point of the solvent and induce crystallization. Conclusion. In conclusion, chemical separation is a crucial process in chemistry that involves separating different components of a mixture. Distillation, chromatography, extraction, and crystallization are some of the most common chemical separation methods, and each has its unique applications. Distillation is used to separate components of a mixture based on their boiling points, while chromatography is used to separate components based on their affinity for a stationary phase and a mobile phase. Extraction is used to separate a compound from a mixture using a solvent, while crystallization is used to induce a compound to crystallize from a solution. Understanding these methods of chemical separation is essential for the production of many products. Distillation is a process of separating a mixture of liquids or a liquid and a solid by heating the mixture to produce vapor and then cooling the vapor to produce a liquid that is enriched in one of the components of the mixture. This process is based on the principle that different components of a mixture have different boiling points, which means they will vaporize at different temperatures. There are two main types of distillation: batch distillation and continuous distillation. Batch distillation is used for small-scale production or for laboratory-scale experiments, while continuous distillation is used for large-scale industrial processes. Batch distillation. In batch distillation, a mixture of two or more liquids is heated in a still until it boils, and the vapors are then condensed and collected. The first distillate that is collected is usually rich in the most volatile component of the mixture, while the remaining liquid is enriched in the less volatile component. Batch distillation is a simple and economical process that can be used to separate a wide range of mixtures. However, it is not very efficient and can be time-consuming, especially for large-scale production. Continuous distillation. Continuous distillation is a more efficient and automated process that is used for large-scale industrial production. In this process, the mixture is continuously fed into the still, and the distillate is continuously collected. Continuous distillation can be further divided into two types: fractionating distillation and steam distillation. Fractionating distillation. Fractionating distillation is used to separate mixtures of liquids that have different boiling points. The mixture is fed into a column that contains a series of trays or plates, each with a condenser. The trays are arranged in such a way that the temperature decreases as the mixture moves up the column. The vapors produced by heating the mixture are then passed through the column, and as they rise, they condense on the trays that have a lower temperature than their boiling point. This process allows for the separation of components with different boiling points. Steam distillation.